Good evening, my name is Jeffrey Lashley. This is week 3 to FTH 202 Revolver. I'm going to show you a safe, empty revolver. I have no ammunition in my workspace. This week we're going to talk about cycle operations and specific parts. And I have, first thing I'm going to talk about is the hand. This item right here, the hand, if it was to failure, to operate, it would not chamber or lock. So whenever it moves up, it would chamber the next round. If that fails, it's not going to chamber and it's not going to allow it to move forward and then lock. The next is the sear. The sear is this small piece right in here, and it would fail to cock. So it would not cock the hammer back and would not allow it to stay if there was a failure of cycle operations there. The cylinder stop. The cylinder stop is this item right here, this entire loop that comes up here. If that fails, then it is not going to allow it to lock in place whenever it comes and engages in these areas right here of the cylinder. The next one is the hammer strut, which is right here, which houses the spring. Failure to cock and fire. So whenever the hammer is cocked, it loads it, and then the force, whenever the trigger is pulled, will drive the hammer home. In that manner right there. Those are the 4 pieces that we needed to discuss this week. Next I will move to measuring the twist rate and show how that is measured. Alright, so we're going to measure the twist rate of the Taurus 856. We're going to take a rod and with the jag on the end. We're going to take a patch and put over the end of it. We're going to have a piece of tape here that'll show us the actual angle of the twist, or the rotations of the twist, if you will. So we'll put this in with the tape being straight up and down, and we will push it in, start it, and we'll watch the tape here, and then slowly start pushing it in. Sometimes it may need a little force to push it in a little bit, as you see the tape starts to move, and then I'm going to hold my hand on the back to make sure that it doesn't come too far out of the back. And right there is where the end of it is, so that was about 1/8 of a rotation, just like in the class, is what I'm estimating. And therefore I would mark my distance of how far it's in there, and then I will measure from there. I will measure from the end of the jag to the mark, and that is literally, let me see if you can see it in there, 2 inches to the mark. It's just a little bit over, just depending on whether the point is what's making it go over. The point was not going to make the rotation go, so I would reduce that a little bit. It's right at 2 inches. So 2 inches at 1/8 of a rotation. So I would multiply 2 by 8, and that's 16. And therefore it would be a 1/16 twist rate. I checked that against Taurus.com. I'm not going to read all this out, but here's the actual reference of what I looked it up. And also I googled Taurus 856 38 special, which took me to the Taurus website that has the specifications on there for a 1/16 twist rate. But that's it in a nutshell. It's fairly easy to check the twist rate. Very short barrels though, so you have to watch that flag. It's not going to turn very far, so you kind of estimate it about 1/8 of a turn. That concludes this week. Look forward to the final 2 weeks of the course. Thank you. All right, I realized in my last section there that the reference was backwards. So here's the reference for my twist rate, 1 16th. There's the website. Like I said, I Googled Taurus 856 38 special, and it took me to the taurususa.com to show me that. Thank you.